welcome again to the Math Studio with me, Professor Rivers. The plan for today is to start our third module, probability. This is part one. We're going to talk about fundamental counting principle, permutations, and combinations. So first, to start with the fundamental counting principle. So imagine that you're buying a new car. You've got two body styles to choose from, sedan or hatchback. There are 5 colors available: black, orange, lime, blue, and sky blue. There are 3 models. You have the GL, which is the standard, the SS, which is the sports model with a bigger engine, and the SL with luxury, this luxury model with leather seats. We want to know how many total choices do you have. So you can see in this what's called a tree diagram the different ways that this can play out. So first, you can choose either a sedan or a hatchback. If you choose a sedan, you have the 5 colors to choose from. And then once you choose a color, you have the 3 styles to choose from. And so you can see that the way that this branches out, if you then count all of the possibilities in the last row down here, right, you get 30. So you can count them all, and you can do this each time you're faced with a problem, but you can also do a simple calculation. So you have the 2 styles of car, the 5 colors, and the 3 styles here. So if you multiply the 2 times 5 times 3, you get 30 total choices. And you can do that without a diagram. That's basically the idea behind the fundamental counting principle. So let's take a look at an example. You have a lock that has 4 dials. On each dial are the digits 0 to 9. How many possible combinations are there? Well, for the first dial, you have the choices of the digits 0 to 9. And those are 10 choices. For the second number, again, you have 10 choices. For the third, 10, and the same for the fourth. Now, they didn't say that you can't repeat numbers, so therefore we can use 10 each time. So we have 10 times 10 times 10 times 10, or 10 to the 4th power, which gives us 10,000. So there are 10,000 possibilities. We can do a question like this where we ask about different possibilities for a password. So let's say that you have a website that requires users to set up an account that is password protected. If the password format is 4 letters followed by a single-digit number, how many different passwords are possible? So let's use a similar approach. For the 4 letters, we have the 26 choices for the first letter, multiplied by 26 for the second, and so on. That's the first 4 parts of the password. The 5th is a single-digit number, which again means we have choices from 0 to 9, which is 10 choices. So you can see that there are going to be a lot of passwords possible. It means multiplying 26 by itself 4 times and then times 10. I'm going to let you try this one, and then we can talk about it some more in class. So next semester, you're planning to take 3 courses: math, psychology, and biology. There are 5 sections of math, 3 of psychology, and 7 of biology that you find suitable. Assuming no scheduling conflicts, how many different 3-course schedules are possible? Let's talk about permutations versus combinations. To get into my gym locker, I need to enter the numbers 21, 16, 3. Is this the same as entering 16 followed by 3 followed by 21? No, it isn't the same. The order does matter. And so this is an example of a permutation. When making a fruit salad, I like to put in grapes, melon, apples, and some clementines, or any other citrus. Does it matter what order I put these in? No, here the order doesn't matter. I just want a fruit salad. And so this is an example of a combination. And so actually, when we talk about combination locks for our gym lockers or whatever other lockers you might have, they really should be called permutation locks, since the order that we enter the numbers in very much matters. All right, so a little bit more about permutations. There are two types. There's the type where repetition is allowed. So for example, a password that allows AAAA111. There's a second type where the repetition is not allowed. So for example, you have a swim relay and you have first, second, and third place. Those must all be different people in terms of those place winners. We'll examine both of those types. So let's start with an example of a permutation. So a special type of passwords consists of 4 different letters of the alphabet, where each letter is used only once. How many different possible passwords are there? I encourage you to pause the video and try this. So how we're going to do this is for the first letter, we'll say we have 26 choices. But now that we've chosen a letter from the alphabet, we don't want to repeat it. So the second letter has only 25 choices. The third has 24, and the fourth only has 23 to choose from. If you multiply those out, you get 358,800 different possible passwords. Another way that we can write this is P264, or 26P4, which is calculated by doing 26 factorial divided by the difference between these two, 26 minus 4, which is 22 factorial. Factorial means starting with 26 and multiplying all the way down until we get to 1. So in the denominator, we have 22 all the way down until we get to 1. You'll notice that a lot of these are going to divide out to 1. So all of the 22s onward, they're all going to divide out. And what are we really left with is, once again, this 26 times 25 times 24 times 23. So this is just another way that you'll see it written. Okay, so for combinations, there are also 2 types. But remember that with combinations, order is not important. So repetition allowed is one type. So for example, you'd have a bunch of coins in your pocket. So you'd have like 3 nickels and 4 dimes, and it doesn't matter, right? They're all kind of jammed up in your pocket. It really doesn't matter the order in which that you have them. Repetition not allowed. So think about the lottery. When the numbers are chosen one at a time, and as long as you have any combination of those numbers, you'll win. So the fact that you had it first, second, or third is not terribly important if you had all those numbers. So let's look at an example of a combination. So the way that they're going to be written is with NCR. So C for combination, N is for the objects you have to choose from, and R is how many objects you're choosing. Here the formula is a little bit different. So N factorial in the numerator divided by R factorial, and then the difference N minus R factorial. Now the reason why here we're adding this R factorial in the denominator is, remember, we don't care about the order. So we have to take out a lot of the stuff that's been repeated, because 1, 2, 3, 4 is the same as 4, 3, 2, 1, and we don't want to count that twice. Another way you'll see combinations is in parentheses like this with N over R. This is also known as the binomial coefficient. For those of you who are going to study a little bit more math, it's going to be really cool and important. N is the number of things, again, that we're choosing from. R is how many we're choosing. There's no repetition, and order doesn't matter. For example, you have James, who's the chairman of a committee. In how many ways can a committee of 5 be chosen from 10 people? Since there's no indication of order being important, we use combinations. We're going to do 10C5, which is 10 factorial over 5 factorial, and also divided by the difference 10 minus 5 factorial. That plays out as 10 times 9 times 8 times 7 and so on, divided by 5 times 4 times 3 times 2 times 1, and again 5 times 4 times 3 times 2 times 1. If you simplify that, you get 252. I encourage you to pause and double check that you also get 252. Therefore, there are 252 ways to select a committee of 5 from a total of 10 people. Some final thoughts. So if we're asked how many different combinations of 1, 2, and 3 versus permutations of 1, 2, and 3, which one is which? So where order does matter, where 1, 2, 3 is different from 1, 3, 2, from 2, 1, 3, and so on, we're going to call that permutation. Where the order doesn't matter, so 1, 2, 3 is treated as the same as 3, 1, 2, and all of these is just treated as one combination, that's a combination. So order doesn't matter.